The DeFUD Podcast.
Model has been updated to reflect the new changes in the permissions, and now he's able to get the answer. Again, if I remove the permission back, the model will get updated again, and it will again remove the permission for that particular user for this answer. So this, in some sense, tries to solve the problem of information sharing in the companies while still being able to perform the governance and access controls that you want in your data, and not everybody being able to see the answers.
Yeah, that sounds pretty cool. The fact that there is a translation of topics happening to documents all seamlessly in the backdrop, and you're still using a rule-based system, the classic ACLing that we are so used to, and your vectorization and embedding around documents to permissions seems to be working seamlessly here. Superb job here. Hello and welcome to the DeFUD Podcast. In this episode, we have Saurabh Shintre, founder of Langsafe.ai, which is an LLM security company still in stealth mode. Prior to starting Langsafe, Saurabh spent significant time at Splunk and Symantec doing ML security research. Saurabh also has a PhD in computer science from CMU. Over to you, Saurabh. If you would like to add anything, please do so now.
Yeah, the only thing I would add is that my primary area of research in the last 8 years after my PhD has been on security of machine learning systems, but also have done a lot of work on using machine learning for security products. So generally have been in this space for quite a bit of time now.
Very cool. I think adversarial machine learning and now generative AI and security around enterprise data, they all seem to be linked together. I'm pretty sure you'll offer us good insight into how that has progressed so far. So maybe I think we can start with some of your own experiences that have led you to jump the ship and going from a practitioner of ML security to a founder in this space. Maybe you have some stories to share there.
Yeah, absolutely. So as I mentioned before, I've been in this space now for a long time. So I joined Symantec in 2016. And just a few years earlier, around 2014, some of the earliest papers on machine learning security or adversarial machine learning started to come about. And the story behind that research was that while ML systems were performing better day by day, they were found to be extremely vulnerable to adversarial manipulation. So an adversary, either at training time or at inference time, would be able to manipulate the data that is being used to make predictions. And we are talking primarily about predictive systems at the time. And the behavior of the model or the performance of the model could be completely manipulated and broken down because of this adversarial presence. So my interest in the space, being at a security company and having some background in ML, we found this problem to be extremely interesting. And over a period of time, this problem has been worked upon quite a bit. It was one of the hottest areas of ML research around that time. The fundamental difference that people often do not realize about ML security is that unlike classic software security, where most of the issues are caused because somebody wrote a bad piece of code or they were not thorough about their reasoning, ML systems fundamentally have architectural security issues. They cannot be wished away by coming up with a different model or reshading the algorithms and so on. Neural networks, which still form the bedrock of even the transformer architecture, continue to suffer from these problems. As now we have graduated from predictive systems to generative systems, particularly the ones which focus on languages, it became very clear to me last year that the performance of these systems in normal setting is quite superior to anything else that we had in the past, and that enterprises would build a lot of workflows and automation on top of these models. But knowing what we knew about these security issues with ML, particularly the fact that they have still not been fully resolved, we knew that enterprises are going to struggle building robust and trustworthy and reliable applications using AI. And given sort of the opportunity and just the impact that we could have had in this field, I decided to leave my job at Splunk and build a company around it.
Very cool. So I hear from you that going from classic predictive systems in the ML world to generative systems in the AI world, the performance being so great that you see a huge potential for uptick in generative AI being adopted much more widely than what the classic ML systems would have been. And we still have to solve the enterprise data security problem there. Yeah. And I'm pretty sure there's more than one approach to solve for that problem. I'd love to get your opinion on what you have seen and what you have observed as possible approaches to enterprise data security problem in the context of generative AI.
Yeah, let me preface that by saying why data security is important for AI. So at the end of the day, for any enterprise to be able to get better answers from these AI systems, they need to connect their data to that. Because base models that come out of the box have no clue about your enterprise's internal data or private data, as they should, right? So they can give you general answers about who is Steve Jobs or XYZ, but when you ask them specific questions about your enterprise, the model has no clue. So how do you give this additional context to the model for your use case? And you have a few options there. The first one is that you either stuff all the data into the prompt or the context window of the model. In the beginning, this was a little bit hard because the context windows were quite short. Now we have the latest models from Google, which have about 1 million token context window. So you could maybe do that. The other option is what is a vector database or a retrieval augmented generation system. But based on the query, you identify what is the most relevant piece of information that can be used to perform this query. You put only that part in the context window. This also comes with its own limitation. And the last one is that you fine tune the model as such. You take a base model and you take your data and you fine tune the model for your particular use case. The biggest concern with this is that enterprise data, unlike public data on which ChatGPT and others have been trained upon, which comes with no access control or permissions restrictions, enterprise data is usually heavily permission controlled. Not everybody should be able to see everything in the model, or data belongs to certain people. And in that case, we have a lot of governance systems that are built upon our raw data sources. It could be a traditional databases or SaaS applications and so on. But when you pull the data out from those stores and put them into this model, either you're fine tuning or you're putting this data in vector databases, you actually lose a lot of that control that you require for an enterprise grade application, because vector databases do not quite support RBAC and other kind of primitives right now. And when it comes to fine tune models, you actually have no way currently of even knowing how to do this. How do you make sure that the model only responds for a particular question, only responds to the person who has access to that information and not respond anything otherwise?
Yep, I agree with you, because even though the scenarios around context window being populated by vector DB and RAG systems versus direct training at the prompt, the underlying notion on who should have access to any piece of information, text, knowledge, or data, that construct is always in the mind of the business, but not necessarily easy to encode in the LLM application. If I'm following your drift right, that's where you're going at.
Yeah.
Very
Yeah.
cool.
And the current ways of solving this problem, there are a few companies that have been around that kind of try to tackle this problem in a previous version of the issue. But at the end of the day, the best solution right now, or the most popular solution, I would say, is that, okay, I'm going to take all my data and I'm going to vectorize it and put it in vector DB. And then either as I pull in the vectors, the relevant vectors for a query, I'm going to do a permission check on whether this user has access to these particular vectors or not. Now, there are certain interesting issues that show up here. The first issue is that it's slow, because first you're going to pull up the vectors and then you're going to do a separate call to check for permissions. And AI systems or AI applications already suffer from a lot of latency issues because the models themselves are slow. So you actually do not have a lot of budget to be able to do these things. The second problem is that vector search itself works fundamentally differently than your classical database search. So when you go and ask a vector to give the top 3 or top k nearest neighbors, it's going to give you those neighbors. And then let's say you go and check and find out that, by the way, all the neighbors that I pulled, I actually do not have access to, or this particular user doesn't have access to them. Then you return empty-handed. And even though there might have been better relevant documents which you actually did have access to, but in this way you've orchestrated the permission, you just end up losing all the documents that you've pulled from the vector DB. So in that case, your quality of the responses can be absolutely poor by doing the separate permission checks. When it comes to fine-tuning the model, by the way, there is just like currently not a lot of people know how to do this. Everybody's scared about the fact that I'm going to put any data in the fine-tuned model, it could be leaked. A trivial solution for that is that I'm going to focus on coarse-grained permissions, let's say, and I'm going to train models with respect to those permissions. So I'm going to train a separate model for finance. I'm going to train a separate model for engineering. I'm going to train a separate model for marketing. The problem is that information in this enterprise, any large enterprises, you're going to have significant overlaps in this information. And then you can very quickly increase the number of models that you have to support and keep updating that can actually support all of your users and their different use cases. So an ideal solution would be that you would have one model that basically has all the information that you need from an enterprise, but then also has these concepts of access controls and only answers questions to the right people.
Interesting. So I can certainly see the limitations with the nearest neighbor fetch problem augmented with you don't have the right authorization. And I can see the complexity on silifying department-wise models if you were to train models for specific use cases. So what are you proposing here, Saurabh? Do you have some other way of tackling this problem?
Yeah, so I think we have a couple of different ways in which we are trying to solve this problem for different use cases. Right now, we are solving the use case with retrieval augmented generation, where you take your content, you convert them to embeddings, and you store the embeddings in the vector DB. And here our approach basically is to change those embeddings in a way that also encode access information. If you go give a piece of content to OpenAI and you get the embedding back, the embedding is dependent entirely on the content of the text and nothing to do with the permissions or metadata. What we do is that we have built a novel embedding system, which essentially also encodes, along with the content of the data, also encodes its permission, and that's what gets stored in the vector DB. So when a particular user performs a search on the vector DB, the search is performed only on the data that they have permissions for and on nothing else. And all of this is done in just a single query to the vector DB. So you don't have to worry about either having to make a second call to a permissioning API, nor do you have to worry about the fact that the data that you might receive might be rejected, because all the search happens only in the permission space that the user can see. And I can give you a demo.
Wow, that'll be super cool. Before we get to the demo, I think your previous critique of other approaches was performance. It's not super clear yet, based on your narrative, how would your method be performing better than any other methods?
Yeah, so I would say, as I mentioned, that in our case, this creation of vector DB is done in a certain way that the search itself is permissioned. In that case, you can imagine that you don't have to worry about any other secondary checks or filtering or post-filtering or pre-filtering of the queries that you're making. As soon as you know which user is making the call, the vector DB itself, in some sense, returns you the document that are both relevant to the query and are also documents that the user has access to in a single call. So that almost saves you like one round trip time, if nothing else.
Gotcha. So compared to this approach that you're taking, where the permission and the authorization information or encoding is close to the data or information itself, how do you see this approach complementing or negating the need of some of the other approaches that I've heard around this issue of data security by doing classical things like output filtering, DLP thinking at the orchestration layer, where based on the logged in user context, you may not get anything back because you don't have the right permissions to the type of information coming out of the model. How do you compare and contrast these things?
Yeah. So I think at the end of the day, both approaches are trying to do the same thing, which is to make sure that the wrong person doesn't get access to the wrong information. But the problem with input-output filtering, and I worked in Symantec, I worked very closely with DLP product that we had. The issue with LLMs, which makes it particularly hard to apply DLP level controls, which sit outside the model or outside the AI application and just only filter on the input and outputs, is that the way in which you can query and get back data from the model are actually far too complicated. And it's really hard to build rules that cover all the ways in which it can be manipulated. And we have seen this already in many firewall kind of approaches that we've taken. When you look at something like DLP, a classical DLP basically will look at the output or input to the model and identify, let's say, certain types of patterns like social security number or XYZ. The problem is that in the previous world, if you didn't hold on to that pattern, your regular expression or whatever rule that you've created would obviously fail. But the system on the other side was also not that smart, so it would not be able to function on any kind of manipulation. The problem that happens with LLMs is that they're actually quite smart. So even if I send it a manipulated or a transformed way of sending the social security number, which bypasses the rules of the DLP, the model, on the other hand, would still be able to understand what I'm talking about. So just to give you a precise example, if I replace a numerical 1 in a social security number with an English equivalent, ONE, or a Portuguese equivalent, UNO, it will bypass all your DLP filters. But on the other hand, because LLMs have been trained on this information, they still know that the English ONE or the Portuguese UNO is the same as the numeric 1. They would still be able to operate on that information. Building these kinds of rules on the outside is really hard against natural language.
Yeah, you're absolutely right. I can totally see that it's no longer a rule-based system. It's an understanding semantic system. So
exactly,
the variation in the rule base is going to be explosive to manage. It's going to be hard that way. I can relate to that.
As an example, so we have a lot of companies that are creating rules for detecting prompt injections, which are of very simple nature, reveal all instructions or do anything now machines. Okay, there are a few use cases against which you can build very easy rules. But when you saw what happened with the poem attack on ChatGPT, where when you ask it to repeat the word poem infinite number of times, it does so for like about 40, 50 times, and then it just starts leaking all of its training data verbatim. No rule maker, no security rule maker in their right mind will ever make a rule against the word poem because it's just not a bad word, right? But again, how this word or how a sequence of this character is going to be understood by LLM is very different than what you and I think about. So unless you build these security rules in the embedding and in the understanding of the model itself, you're going to have a very hard time trying to make any kind of rules on the outside.
Yep, I agree with you. Let's take a look at your demo.
Yeah, here we are going to basically give you a demo of how can enterprises build their own Perplexity or chatbots on their own internal data while still performing or while still enforcing the permissioning that you require on that data, right? So not everybody would be able to see all the answers. So typically what we have done for a setup is a very simple setup. We have taken all the public meeting minutes of the Federal Open Markets Committee's meetings, and we have created 4 personas, which are the 4 Federal Reserve Chair of the past 20 years or so. And the idea of access here is fairly simple. If you're present in a meeting, you should be able to ask questions about that meeting. And if you're not present in that meeting, you should not be able to get any answers. So in this particular case, let's say these meeting minutes, much like how our current enterprises were stored on Box, let's say as a data source. Of course, we support a lot of other connectors as well. In that case, you will just be able to give your client secrets and be able to connect Box to our system. And now we have basically a chatbot here. And now let's say if the user who was logged in is Alan Greenspan, who was the federal chair during the late 90s and early 2000s, who was present in all the meetings when 9/11 was happening, right? So if he asks questions about what was the impact of 9/11 on the economy, he should be able to get answers to this particular question because he was present in those meetings and he has access to them. So our authorization checks basically tells them that, yeah, you are authorized to see these answers and you get those answers. On the other hand, if he asks something more recent when he was not present, what was the impact of COVID-19 on the economy? Pardon my typing. Then the system should be able to know that actually Alan is not authorized to see answers to that kind of question because he was not present in those meetings, and it will return it a different answer, which is I don't know. But let's say for whatever reason we are able to share this information with Alan. So I'm going to go into my Box account and I'm going to give permission to Alan, let's say for this particular document, and just add him. So now I've given permission to Alan to be able to see these kinds of answers or these documents. I'm going to go back to my Box connector and I'm going to update the permissions. So our system is then again going to crawl Box and be able to figure out the new changes to the ACL, update our models based on that. And now in this particular case, Alan would be granted permission. So if we now go and ask the same question by Alan, he would be able to get answers to that particular question. Let's see. Yeah, there you go. In that case, the model has been updated to reflect the new changes in the permissions, and now he's able to get the answer. Again, if I remove the permission back, the model will get updated again, and it will again remove the permission for that particular user for this answer. So this, in some sense, tries to solve the problem of information sharing in the companies while still being able to perform the governance and access controls that you want in your data and not everybody being able to see the answers.
Yeah, that sounds pretty cool. The fact that there is a translation of topics happening to documents all seamlessly in the backdrop, and you're still using a rule-based system, the classic ACLing that we are so used to, and your vectorization and embedding around documents to permissions seems to be working seamlessly here. Superb job here.
Yeah. And we have connectors for all the kind of documents, so they can either just mirror the permissions that you have on your data sources, or in our case, we are also making a predictive system, which will be able to predict what kind of access to the information that people should be having, and might even be, or would also be able to give redacted answers to particular users based on their roles.
Yeah, it'll be amazing if you can basically start reading the groups existing in systems like Jira, and you can just use that knowledge to have a default status on what's allowed and what's not allowed.
What's allowed, exactly.
Yeah, that'll be amazing.
I mean, with Jira, Slack, and other things as well.
Yeah, someone gave me an example recently where they were like, I'm going to build an LLM app to make incident management really easy across by looking at Jira tickets. So I'm like, how are you going to ensure that sensitive information in Jira is not going to go to the wrong person? I think this is an answer to that problem in that sense.
Absolutely. Absolutely.
Yeah.
And you will, as the admin, you'll get all the results of what kind of queries your users are making. Are they making queries which are authorized, unauthorized? They have any kind of other violations and so on. So we have a comprehensive system that basically provides you data security, both from the perspective of connecting your data safely to these AI applications, but also during their usage, how do users make sure that they're asking the right questions and only getting answers to things they're supposed to. So it's a comprehensive solution for that.
Very cool. I really appreciate the time, Saurabh. This was very insightful for me. I hope our audience is also going to find this useful. If you have any parting thoughts, please share now.
Yeah, as I said, I think this is still very early days of AI security. Obviously, it's a very nascent field, particularly with LLMs. But one thing we must keep in mind that to the theme of your podcast, which is about DeFUDing, I think we should approach this topic, especially from security, not from a perspective of being scared of the technology, but remembering always that if we got to get our principles and basics of security right, and we might have to change the tooling a little bit, we'll still be able to secure AI. It doesn't change the fundamental of security that much. So we just always have to trust our knowledge and our principles, and we'll be okay.
I'm pretty sure with the engineering expertise like yourself and our belief in our own principles, we'll crack this puzzle. Thank you so much for being on the show.
Absolutely. Take care. Thank you so much for having me.
Thank you for tuning in to the DeFUD podcast. For more hot takes and content, please leave a kind comment and click the buttons below to like, share, and subscribe. Doing so really means a lot.